All right, guys, we're looking at day 14 and we're doing lesson 58 today. So this one may be a little challenging just to do over the video, but we'll have some examples and we have videos we can watch on it in class. So we're looking at symmetry. So we have different types of symmetry that we have. So reflective symmetry, that's a new one, or line or linear symmetry. Means that if we draw a line of symmetry through it, okay, then it would look like a mirror image of itself. So we split it in half and it looks like we have two congruent shapes. Then we would say it has reflective symmetry because it looks like this one triangle is split into two and now it is looking at this other triangle and they're identical. So that's reflective, or we would maybe be asked a question, how many lines of symmetry does this shape have? Okay, an equilateral triangle or a regular triangle would actually have three. We draw here, go here from left to right, or from left to right from this bottom corner, and we would have three different lines of symmetry. So depending on the shape, we may have 2, 3, 4, we may have 0 lines of symmetry. So we just got to think about our shapes and then what they have. So what regular quadrilateral or a square, how many lines of symmetry? Well, we could split it in half this way, horizontally, diagonally, both ways. So how many lines do we have? 1, 2, 3. We have, 1, 2, 3, and 4. So we can go vertical, horizontal, diagonal, or diagonal. So those are 4 lines of symmetry that we would have. Sometimes we'll draw these shapes in a coordinate plane, and we may have a line or an axis that we can use as a line of symmetry. So this shape right here isn't really a polygon because it's got rounded shapes, but it looks like, maybe a pot or a vase or something like that, but we split it in half with the y-axis and it does have symmetry. So you may see some questions about this activity that involve letters or pictures. Does it have any lines of symmetry? And you just got to look at it and see. And then we have rotational symmetry. I can't really do this with the screen, but the easiest way to look at rotational symmetry is to actually rotate it. You can kind of visualize and mentally see it go sideways, 90 degrees to the right, 180 degrees, 270 degrees, and then 360. Okay, if it ends back in its original position and that's the first symmetry that we have, that doesn't count, because obviously any shape you do 360 degrees, it'll end up where it started. So if you have a test or review or your book, the easiest way would be to physically tilt it, on its side, then upside down, then on its other side. And if you had any times where it appeared identical to the original position, then it has rotational symmetry. So of these different ones, if we mentally or actually physically turned our book, we would see, after 180 degrees, it looks just like it does right here. This one, we'd have several turns. This one we'd have 3 90-degree turns, and then on the fourth one, we'd get back to our original position. And then D, I would say, is the only one that does not have rotational symmetry, because it's not going to be until we get all the way back around that does it look like this. So the shapes are obviously always going to look the same. It's just, is it in its original position? So A had 2, B had 3, and C had 4 for rotational symmetry. D was the only one that didn't have any. Okay, so that's lines of symmetry and rotational symmetry. I can apply to polygons, different shapes, but also, we can use it for letters or pictures or things like that. Is there anything that's symmetrical if we draw a line down it? So we'll look at these practice set problems when we return and go from there. That is your only lesson today, so we'll see you in class.